This is 9.4 notes, sector area. How do we calculate not just the area of a circle, but the sector area of a circle? Pause this video, rewind at any time if you need me to slow down or review. So, sector area, remember area means the space inside. So if I were to say, what is the area of this circle? What you would be calculating is the area that the inside of the circle, the space inside of the circle occupies. How much space is that? That's area. Now when we calculate sector area, what we do is we have a certain section. So for example, this certain section would be called the sector area. So not only are you calculating the area of the circle, we're going to be calculating a specific sectional area of a circle. So you should definitely have some experience with area of a circle from previous classes, but I will give you a refresher. So let's get this example copied in our notes. So to find the area of a circle, so area of a circle, the formula for this is pi times the radius squared. Simple as that. So this right here, pi times the radius squared, that's how you find the area of the circle. That's what this represents right here for A, area. So to find the sector area, it is simply the same thing. In fact, we can go ahead and just X this out. I've changed my mind. The sector area will simply be the area of a circle, pi times radius squared. So if we did pi times radius squared, that would give us the area of the entire circle. Sector area is not the area of the entire circle. It's only a specific shaded region, like you can see right here. So what we have to do is we just need to multiply by the certain section that certain piece is. So a full circle is 360 degrees. The specific section that we want for this sector area is 210 degrees. So we're going to multiply this by 210 out of 360. That's the fraction of the area that we want. So all we really need here is the radius of the circle, and we can calculate the sector area. The radius of the circle, as you can see, is 3 inches. That's the distance from the center to the edge of the circle. So we're just going to plug that in. We're going to say pi times 3 squared times 210 divided by 360. So let's go ahead and work this out. Pi. So remember, pi in your calculator is just simply this number. It's the ratio of a circle's circumference to its diameter, 3.1415 ... So we're just going to keep it written as the symbol pi. We don't need to write 3.14. We could just keep writing the symbol pi. Okay, so 3 squared is 9, so pi times 9 times 210, and then in the end we're going to divide that by 360. Let's keep on going. So pi times 9 is 9 pi times 210. So we just need to calculate 9 times 210, and we get 1,890 pi. So this is 1,890, still times pi, but we're going to put the pi symbol on the end. That's appropriate. All divided by 360. And then we're going to see if that number divides 360. So we're going to do 1,890 divided by 360. And we get about 5.25. So it doesn't divide evenly, so we'll go ahead and just simplify it so they both end in a 0, so we can cancel those. And they're both divisible by 3 as well. 189 and 36. So right now after that I have 189 pi over 36. Both of those numbers are divisible by 3. So if I divide that by 3, I get 63. 36 divided by 3 is 12. So now if I'm dividing this by 3, that gives me 63, and this is 12. And I think that's going to be good. That cannot be simplified any further. So I've arrived at my final answer. This answer here 63 pi over 12, and we were dealing with inches, so we want to say inches squared. Whenever we are referring to area, we refer to square units. Notice how we did not multiply by pi. See the pi symbol? We just kept it in our answer the entire way through. This is called exact form. If I multiplied by pi, watch, 63 times, clear that, 63 times pi would give me this number. And then I would have to round it. And if I rounded it, it would no longer be exact. So this is what we call exact form, meaning pi is in our answer. Now, if I ask you to round, that's exactly what we would do. So you would simply just take 63 and multiply it by pi, and that's what we would get, and then we would have to divide it by 12. And that would be our rounded answer. So we would say about 16.5. If we were rounding to the tenths place, we would say about 16.5 square inches is the area of that specific shaded region, not the entire circle, just the specific shaded region. So it's important that you know how to calculate it, but it's important that you understand two different answers here. The first one that I showed you is exact form right here. So 63 pi over 12 was our exact form. And then we just multiplied that out, 63 times pi divided by 12, and that gave us a rounded answer of 16.5 square inches. Skip a line and go ahead and write the next example. Next example says, a beam from a lighthouse is visible for a distance of 5 miles. What's the area covered by the beam as it sweeps in an arc of 150 degrees, rounded to the nearest tenth? Okay, so you'll notice that a lighthouse, a lighthouse is light sweeps all the way around, right? And it would be in circular fashion. So let's say the lighthouse is here in the middle, right? It's shining this light out, and then it sweeps all the way around in a circular motion, right? So eventually at some point, the light reaches only so far. So it's saying that that's 5 miles. So that's going to be the radius of our circle. And it's saying, what is the area covered by the beam as it sweeps an arc of 150 degrees? So let's say it sweeps this way, it comes all the way around, and it gets to this point, which it would be 150 degrees. The question is, what is the area that it covers? So what it's asking us is, what is the area of this portion of the circle, which we would call sector area. This is called the sector area of the circle. So we're going to calculate that sector area. If we were to calculate the entire area of the circle, we would need the formula pi times radius squared. We don't want the area of the whole circle, we only want that certain sector, so we're going to take the area formula pi r squared and we are going to multiply it by 150 degrees. Why 150 degrees? Because that's the sector, that's the degree measure of the sector, the central angle, out of a total of 360 degrees, because that's the full circle. So that's the fractional amount that we want. We know that the radius is 5, so we're going to plug that in for the radius, and we're going to calculate. So we have pi times 5 squared, 5 is the radius, times 150 divided by 360. 5 squared is 25, so I'm going to write 25, and then I need to multiply that by 150. So 25 times 150 equals 3,750, and don't forget you have to multiply it by pi. So we get 3,750 pi all over 360. Now this would be exact form, but we need to simplify, so they both end in a 0. We can cancel those out, and it looks like they're both divisible by 3 again. So I'm going to take 375 and divide it by 3. That gives me 125. And then in 36 is divided by 3 is 12. And that's 125. And I believe that that is as simple as you can make it. So yeah, there's no other number that can divide 125 and 12. So therefore, my exact form answer, this is exact form because we did not multiply it by pi. We kept pi in our answer. So exact form would be 125 pi over 12 miles squared would be area that the beam would cover. Now, if we wanted to round it, so if I said rounded, then we would simply just take those numbers and multiply them. So 125 times pi is that, and then I have to divide it by 12. Divide it by 12, and we get 32.7. So rounded, that is about 32.7 square miles is the area that that beam is covered if it sweeps 150 degrees, like it originally said. So it's important you understand these two answers. That's pretty important, okay? So not only the calculation, ladies and gentlemen, pretty easy. Area of a circle, pi r squared, okay? And then we're just multiplying it by the central angle. In this case, it was 150 out of 360. That's all you're doing. As usual, let me know if you guys have questions or anything else that I can help you with.